Good afternoon, students. How are you doing today?
Good afternoon, sir. We're doing fine.
Good, good, good. How many of you opened your math book?
Good afternoon, sir.
Hey, Lottie D, what's up?
I'm here.
How many of you? By the way, Lottie, what you had for lunch today? Tell me, says ackee and sawfish.
No.
You had ackee and sawfish today again, Lottie?
No, I had fish.
Come on, I told you. Let's see if it will work. Let's see if it will work. The magic.
For breakfast, I have ackee and sawfish for breakfast.
Okay, that means okay. So it's still inside of you then. Good, good. Who is that coming in?
Sir, you need to recalibrate your mic, sir. It has so much feedback.
Yeah. Having some feedback.
Yes.
Sir, you're very good.
Oh, I mean here. I like when you say No, I like when Croswell said that I have to recalibrate my speaker, as if you know me know if I do that. But anyhow, am I coming across better, Croswell?
Yeah, it sounds a bit better.
I wonder if my microphone or feed one. Everybody else hearing me?
It's
okay.
Yes,
okay.
It's not that I'm not hearing. It's that your speaker is very loud.
Oh, it's very loud.
Yes, it's very loud.
All right. Okay, so I can turn it down. All right. So my question is, how many of you? Thank you, Ashantia. It's not my speaker that is loud, it's yours. Anyway, let's go. How many of you opened your math book since we had class last Thursday?
I did
and actually did some work.
I did it on Saturday. I did it on Saturday. I did it on Sunday, and I did.
Nice, I believe you. Nice.
And I did it again.
So
I did it again today around 1 o'clock because I was checking out the second question.
Crosswell, like your system, because you know you out Crosswell. I hear say Sunday, and I don't hear anything else after.
I said Sunday, Monday. I said Saturday, Sunday, and I said today as well because I was doing Unit 2 from the Edicosoft.
Okay, good job. Nice. All right. All right. So, is there anybody? Yeah, tell me about that. I was in a meeting from morning. It ended at 4:41. I'm excited for tonight's class because I'm going to teach a new era tonight. So I want So I was just having a conversation with myself. Are you hearing me now?
Yes, sir, we're here.
Yes, sir.
Are you hearing me?
Yes, sir.
Yes,
sir.
Okay. All right. Thank you. Okay, Leon, no problem. Okay, good. All right. So I'm in commute. So, well, in commute, but stationary, so to speak, for now. So I don't know why it is that yeah, I'm using data, but using very good data, so I should be fine. All right, guys. So I'm going to be building. Tonight's class is going to do like a recap of what we did from the start of Calculus 1. So I'm going to be teaching you a topic that is going to incorporate not only what we did in Calculus 1, but what it is that we did up to last week. So I'm going to teach you a topic that is going to sum up everything that we've learned already. Hence, I started off the question, how many of you did any work? Because if you were lagging behind, oh my goodness gracious, I'm really hoping that you will follow through with what it is that is going to be done. Not a difficult area. Matter of fact, I love teaching this area. It's really, really very nice. Really very nice. So I'm trusting and hoping that you guys are ready to go. You just excited to begin, and I'm equally ready. But this computer is telling me otherwise. And I'm going to let it sing the same song or dance to the same tune I'm singing. All right. So I'm going to be looking at piecewise function. Incidentally, even though only the kind of begs me some parts of last week's class, I'm going to congratulate you, because what I wanted for you to have learned last week, it came out in the lesson. How it is that you can get a limit tending to infinity, positive infinity or negative infinity, and you can predict the limit of the function even before working it out. And that's it's really commendable. So I'm really happy for that. And I'm going to just ask that you just keep up the good work. And the devil is a liar. Just keep up the good work. In that regard, hold on. I have lost my stuff. Oh Lord and Father of all mankind. Oh, come on. Give me a minute. That was calculus 2. Oh, come on. All right, guys, here's the plan. I'm going to ask you to do. I don't know what is really happening. It is just. I just had it up a while ago and it is. I hate when the devil just show up in ugly faces, man. I just don't like when him show up in ugly face. No, I'm ready for this thing. It's just not. Oh, come on. Sure. Are you hearing me, guys?
Yes, sir.
Yeah.
So what is happening? All right. My document is here, but it is just. Sure. Sorry, let me just go to my cell phone because clearly this thing wants me to speak in tongues. Make sure your computer has an active internet connection. It does.
Good evening.
Good evening, Otto. Are you hearing me, guys?
Yes, sir.
Just hearing you.
Okay, all right. I'm happy now. Oh, Lord.
So I wasn't able to make it. I had work last week, so I wasn't able to make it. But I'm watching the video. I don't finish as yet, but I'm going through.
And that's the spirit. Just go through the videos and you should be fine, honey. I promise you. You go through the videos, you will be perfectly fine. All right. Don't worry about you seeing CAPE integrated math on that slide. It teaches topic also in CAPE math, but your system, your set of notes was just not coming up, so I'm just using this instead. All right. So we're looking at piecewise functions, and there are going to be some prerequisite knowledge that will be very important for us to navigate through this topic. Really not difficult. I promise you, really not difficult. Now, factorization is going to be important. Factorization is going to be important, all right? So let us look at an example there. It says x squared plus 2x plus 1. And it has asked me to do some factorization there. Remember, as I said to you before, I'm going to be multiplying the coefficient of x squared by the constant. I'm multiplying the coefficient of x squared by the constant. What is the coefficient of x squared? The number in front of x squared. The coefficient of x squared is the number in front of x squared. All right? So the number in front of x squared in this particular case is 1. The number in front of x squared in this case is 1. And I'm going to multiply that by the constant term. And the constant term is positive 1. 1 times 1 is 1. I need two numbers. When multiplied together will give me 1, but when added will give me 2. Only two numbers in the world are 1 and 1. 1 times 1 is 1, but 1 plus 1 is 2. So my factors are going to be 1 and 1. What I'm doing there, I'm separating, I'm segmenting, I'm dividing, I'm breaking up that middle term every single time. I'm breaking up the middle term into two terms. What two terms, sir? Positive x and positive x. So that 2x is going to be broken up into positive x and positive x, which gives me this term right here. Then I'm going to group. When I group, I'm going to have x squared plus x in one bracket and x plus 1 in another bracket, and x plus 1 in another bracket. Are you still hearing me?
Yes, sir.
Yes.
And are you understanding?
Sir, can you
Yes,
go back
sir.
over it, please? I didn't get it the first time.
All right, come in. So no problem. So what I'm saying to you is, I'm multiplying the coefficient of x squared by the constant. The coefficient of x squared is the number in front of x squared.
The coefficient of x squared is the number in front of. Oh, that would be 1.
And that would be 1. And the constant term is also 1. 1 times 1 is 1. So my factors will be 1 and 1. My factors will be 1 and 1. So what is going to happen is, I'm breaking up 2x into 1 and 1. 1x and another 1x. 1x and another 1x. Following so far?
Yes, sir.
Yes, sir.
All right, good job. Now, I'm then going to be grouping. And when I group, there are two reasons, you know. There's one main reason why I broke up my middle term into 2 terms, because I'm grouping and I cannot group with 2 things in one bracket and 1 thing in another bracket. That don't make any sense. I need equal number of terms in the brackets. I need equal number of terms in the brackets in order for me to do my grouping. So I'm going to put x squared plus x in one bracket. I will always leave the middle sign out. Every single time I would leave the middle sign out. And in leaving out the middle sign, I'm then going to put the last 2 terms in the parentheses. X plus 1.
I see.
Now remember, there's a trick. What is the trick, sir? When the middle sign is a negative sign, the last sign is to be flipped. But this one here is positive, so we're not going to spend any time on that until I move to the second question. What is common between x squared and x would be x. So I take out the x here in the second to last line. What is left is going to be x plus 1. And you can check. X times x gives me x squared, check. X times 1 gives me x, check. What is common between x and 1? And your answer should be 1. Because 1 is a factor of all numbers. 1 is a factor of all numbers. All right? So I'm going to have 1, open bracket, x plus 1. Then I'm going to ask myself the question, what is common between those 2 terms? And your response should be x plus 1. What is in the parentheses? And when I take out what is in the parentheses, to the left of the sign is going to leave me with an x. What is left on, when I take it out from the other side is going to leave me with a 1. So what I'm going to be having technically is going to be x plus 1 times x plus 1. And x plus 1 times x plus 1 is x plus 1 all squares. X plus 1 times x plus 1 is x plus 1 all squares. So factorization is something that you can't miss. Factorization is something that you must get. You must understand it. It is on your curriculum, not only for this topic, but for other topics to come. And that's why I'm saying it's a prerequisite knowledge. You must know it. Any questions before I move? So that's an example for perfect squares. Look at the other example I have that speaks of the difference of squares. Just work through that for me. On your own, really not difficult, I promise you. Just work through it on your own, and we could have a conversation thereafter.
Yes, sir. Give me a second, sir.
No problem.
You want us to find the difference of square for S?
Yeah, just to work the question. I mean, the solution is already there now. I have a solution already projected on screen. What I want of you is to just work yourself through what I have to see if you understand it.
Sir?
Yes, sir.
So you can run back the third line in the under the grouping. The last
You read it out for me.
Sir?
Read it out for me.
All right, so it's x plus 1 equal x plus 1 squared.
You sure?
Go again.
Hello?
Yes, sir, we're here.
Right. So I'm just saying, read out the third line for me. I want you to read it.
All right, so it's x plus 1.
X plus 1.
X plus 1.
Minus 1. No, man, not x minus 1. X plus 1 and what?
X plus 1 equal.
Right. So what about x plus 1 and x plus 1?
Okay, sir. All right.
No, talk to me now.
Well, both of them x plus 1.
Very good. Very good. Continue and I am not trying to embarrass you, you know. What I'm trying to do is for you to speak the language, because sometimes when you speak it, you put it to longer term memory than for me to just repeat and tell you the same thing over. So that's why I'm just asking you to just repeat it. It's not a punitive measure.
Okay, sir, I understand.
Yeah, man. So just talk to teacher. And you're not talking to me. What you not understand? Talk to me.
No, sir, make it now.
No, you don't get it. A tree no want to talk? You have to tell me say you get it. You don't get it.
No, sir, make it. X.
Tell me what you get.
All right, so both of them are square. So x plus x.
Say x times x.
So we have 2x plus 1 in bracket.
Yeah.
So both of them are square. So you can square them. So if I say x plus 1 square is the same thing as the 2 x plus 1.
The x plus 1 times x plus 1.
Yes, sir.
You get it then. Very good. You get it for true. Very nice. Remember, students, I am not here to embarrass anybody. I'm here to help you. So when sir asks you, talk to sir. Please. Very nice. Very nice of you, though. Very nice of you. All right. Let me see now if we can move. Let me see if I can move into. Are you hearing me?
Yeah, we're hearing you.
Okay. Let me see if I can move. Go ahead.
That's where I'm hearing you.
Oh, okay. Good. Excellent. Now, let me move into the difference of squares. It says x squared minus 1. No, it's a trinomial. It's a trinomial. Now, remember for the trinomials, as it suggests, trinomials, you have 3 terms. But in this trinomial, you recognize a term is missing, which is the x term. The middle term technically is missing. So what I would have is just x squared minus 1. So what I'm doing, I'm rewriting the question, including in it my placeholder. Including in it my placeholder. What is my placeholder? 0x. Then so you have to do it like that all the time. When you get mature mathematically, you don't have to do that. But outside of that, you're going to use it for now. So I'm putting my 0x as my placeholder. So now I have my 3 terms. What are we going to be doing? The same thing. Look for the coefficient of x squared, multiply it by the constant. What is the coefficient of x squared? Answer. What is the coefficient of x squared?
1.
1. Excellent. What's the constant term? Very good. -1. -1. So the methodology is multiply the coefficient of x squared by the constant. Multiply the coefficient of x squared by the constant. Now, when you multiply 1 by -1, you're going to get -1. Hear my story. I need 2 numbers. When multiplied together, will give me -1. But when added, will give me 0. But when added, will give me 0.
Sure, 1 and -1.
Yeah, -1.
1 times -1.
1 times -1. Excellent. 1 times -1. So what I'm going to do now is to say x squared minus x, which is really -1x, plus 1x. And if you see what is happening here in the middle, plus x minus x gives me 0. So really and truly, it comes back to my middle term going away. Are you following there?
Sir.
So even though there is no middle term, I still have to use my placeholders so that
Sir?
are you hearing me?
Yes, sir.
Yes, sir. Hearing you now.
Okay, cool.
Yes, sir. Hearing.
All right, thank you.
They're a bit low though. Like
No problem.
Mic.
That I can fix. Are you hearing me much louder now?
A little bit. Can try again.
All right. Any better?
Yes, sir. Way better.
All right, good. So, what is going to happen is when I group those two terms, I'm going to end up with x squared minus x in one bracket, x squared minus x in one bracket, and then for the other one, I'm going to end up with a x minus 1 in the other bracket. And then I'm going to go through the factorization just as I did before in the first question. What is common to in the first bracket between x squared and x? And your answer will be x. So I'm factoring out the x. What is left? It will be x minus 1. It's actually x squared minus 1. It will be x minus 1. Then I'm going to ask myself a question again. What is common between x and negative 1?
What is become? You're talking for difference of squares, right?
Right. And your answer should be negative 1. Sorry, positive 1. Because 1 is a factor of all numbers. So it should be 1. Now, when you factor it out, you're going to ask yourself a question. What is common there? Your answer should be x minus 1. And when you factor the x minus 1, you're going to end up with x plus 1. And this is what we call the difference of squares. Why is it called the difference of squares? Compared to the first one, you have exactly the same thing, except that the signs are different. You have exactly the same thing, except the signs are different. In the first example, you have x plus 1 times x plus 1. In the second example, you have x minus 1 times x plus 1. So in the first one, you have a perfect squares. And in this one, you have a difference of squares. You have the difference of squares. All right? Are you still with me? Are there any questions?
So just run through it one more time, sir.
Okay, tell me what it is that you're not seeing.
Sir, I want to take a note of what you said about the x squared minus 1, the constant. But yes, that part I want to make a note of.
Yeah, but remember now, the same thing that I did before is the same thing that I'm now doing. It's not changing. So I'm multiplying the coefficient of x squared by the constant. The coefficient of x squared is the number in front of x squared.
Okay, sir.
Right. And which is the same thing that I had said when I was doing the other one. All right. And then when I multiply the constant, which is negative 1, by the coefficient of x squared, I'm going to end up with negative 1. Now I need to find my factors. Two numbers, when multiplied together, will give me negative 1, but when added will give me 0, because 0 is my middle number. Now, in mathematics, we call this the inverse. When two numbers are added and you get 0, one number is the inverse of the other number. So 3 minus 3 equals 0. It means that 3 is the inverse of minus 3, and minus 3 is the inverse of 3. So whenever two numbers are added and the result is 0, one is the inverse of the other. Just remember that.
All right, so let me just get that straight. When you have two numbers which are like say the positive or negative aspects of each other, like say 2 and negative 2, that's an inverse.
Yeah.
And when you're doing the reverse operation where you have to use negative 2 and 2, it's the same process.
Yeah, man.
And that is known as an inverse.
Yeah, man. So whenever two numbers are added and the sum is 0, it
Okay.
means that one number is the inverse of the other. Any two numbers, negative a half plus a half equals 0. One is the inverse of the other. Always. All right? Okay. So what I did just now was just a little warm up. That's not the topic for tonight. What I did was just a warm up. The topic for tonight is going to be called piecewise function. All right? Now, what does, when somebody say to you, piecewise, what do you think they're talking about? Explain the word piecewise for me.
They work the question in stages. Something like that.
Oh, who said that?
Piece by it.
Piecewise. Piecewise. Who said that a while ago? Who answered that a while ago? Not Croswell. The person before Croswell.
I mean, sir, but I didn't know I was right.
You know, but you see, that's the
What was the
problem.
answer?
That's the problem. You're doubting yourself, so you don't want to talk. Go again and tell. Croswell is asking what you said.
No, sir, I just said I have to work the question in stages.
Right, and that's it is. So you're working the question in stages. You're working the question. You didn't want to use but the word piecewise, but you're really working the question in stages. Right? You're working the question in stages.
Sir.
Yes, please.
Sir, my Wi-Fi did trip out a while ago. You can go back over, please, because I missed as I started to say different of squares. It went.
Not a problem. So I'm saying the difference of squares is where you have one being positive and the other one is negative. And I was saying to you, the sum of those numbers is going to give you 0. And whenever you add two numbers and you get 0, it means that one number is the inverse of the other number. When you add two numbers and you get 0, it means that one number is the inverse of the other number. All right? So and then I moved into now piecewise, and I think Leon was saying, and I think Leon was saying to me that you know, when you work it in stages, sir. And I said, okay, stages, all right, cool. So stages is going to be taking it piecewise, and that's a very good response, Leon. And Leon, I'm going to say to you, whenever sir asks question, is me tell you say you're wrong. You don't tell yourself say you're wrong. That's what Excel is paying me for, and the Ministry of Education is paying me for, to tell you that you are wrong. I want you to speak to me, and that was very good, excellent. So I'm working it in stages. So let me give you an example of what it is that we're doing in stages. Now, if you look at that question, let me read the question for you. It says, determine if f of x is continuous. Hold on, sir. Hold on. Continuous? All right. Do me a favor. I want each of you to take your implement now, and I want you to write across a page, do some waves without lifting your implement. Make a little wave, wavy stuff in your book with your pen or pencil or crayon. Write across one line of a book without lifting. And let me know when you have that done.
So you want us to make a
Do
wave
it without what, sir? Didn't hear you. Said
without lifting your implement.
So you want
Just do the wavy line without lifting your implement.
Sir, to be honest, I don't understand what you're asking us to do.
All right.
You want us to make a continuous wavy line. That's what he wants us to do.
With your pen, with your pen.
With the pen, yeah, a continuous wavy line.
Just don't lift up the pen.
Just don't lift up the pen. Just make some, like when you try to say for a pen and write, I do some scribbling. Yeah, but you're not going to lift up the pen.
Oh, okay,
right.
Okay.
So that is an example of a continuous line. in the other example, what I want you to do for me now is you're going to make that same way with something, but you're going to lift the pencil or the pen, and then at some point, and then you're going to continue, and then you lift it at another point, and then continue. So you have breaks in it. You know, sometimes when the Wi-Fi connects and it is unstable, and then it breaks, and then you get logged out of the meeting, and then you have to log back in. There's a break in the connectivity. That's what we call something that is discontinuous. That's what is called discontinuous. So that's what it is. So you have a continuous line and a discontinuous line. Now, what it is that they're asking us to do is to determine if f of x is going to be continuous at x equal 2 and x equals -2. When you want, so when the graph is plotted, you get a continuous line. We're not ready for the sketching of these graphs yet. We're not ready for the sketching of these graphs yet. What it is that we're ready to do is just to see if we can work the question. All right, so let's go. I want you to think, I want you to imagine something for me. And what I want you to imagine for me now is a number line. Imagine a number line for me. Is everybody with me? Imagining that number line?
Yes, sir.
Yes, sir.
Yes, sir. Yes, sir.
Tell me what sets of numbers are to the left of the number line.
Negative.
Negative, sir.
Negative numbers.
Leon, you're answering me again, and you're answering me
Negative, sir.
very good. Leon, you're answering me and you're answering me very tentative. I'm going to shake out your lunch money.
No, sir, I wasn't the person who answered.
Oh, you weren't the person. Oh, okay, I have forgive me. He must talk to me now so I can differentiate the voices. All right,
Yes,
but very
sir.
good. Who was that a while ago and said negative?
Me, sir.
I know. No, me who? Tell me the name.
Or Danny chats.
Dane. Okay, Dane. Yes, Dane. Very nice, Dane. You're talking up in class. Love it. Very nice. But Dane, I want you to speak confidently. If you're wrong, let me tell you say you're wrong. But yes, negative numbers are to the left of the number line. It will never ever change. And of course, if negative numbers are to the left of the zero on the number line, it means that to the right of the zero is going to be your positive numbers. To the right of the zero is going to be positive numbers. All right? Okay. There are many different concepts that I need to talk to you about in this. Many different concepts. Many different concepts. Now, I want you to, let us read the first part of the piecewise function. The first part of the piecewise function says 2x minus 1. 2x minus 1. And this semicolon can be read as such that x is less than -2. Does everyone agree that this inequality sign, sometimes called an inequation sign, is a less than sign?
Yes, sir.
It's a less than sign. All right. Wow, less than, less than. Less than connotates what set of numbers?
You mean in this instance?
Yeah. When it says something that is less than. Okay.
In regards to this question, since it's
in regards to the number line, when I say less than, which direction am I going?
You're going to the
negative side, sir.
To the negatives, and which side is negative? Give me some cardinal direction. Which side is negative?
Left side.
Very good. Left. So we're going to the left.
Anything that is less than -2 would go with the increment to the left. Wait, that didn't sound right. Anything that is less than 0 and going to -2 increments to the left.
Right. Correct. You're correct. But what is happening though? What is happening is equally true. you don't have to have, it's like we have a negative 2 right there, Crosswell.
Yes, sir.
It could have been x is less than 5. But 5 is going to be positive. I don't want to answer you yes, because I don't want you to think that because I have a negative 2 there, that's why you gave me the response you gave me. Because I could have had x is less than 5, and 5 is a positive number. It is better for me to tell you less than is to the left. So when I'm at 2, negative 2, it means that I am going to the left of negative 2. Am I clear?
Yes, sir.
All right. So it said, and I want you to work with me now. I want all eyes on the board. All eyes on the board. I'm going to bigify it so that you can see what is happening. 2x minus 1 such that x is less than negative 2. The intuitive approach is here to haunt one more time. To the left of negative 2, I now need to investigate what is happening.
Okay, so that's how you read it.
Right. So look at what is happening here now. So if you look at me, so look at what I have here. At x equals negative 2, at x equals negative 2, this is what I have. I'm going to be evaluating the limit as x tends to negative 2. But do you recognize that I have a superscript, which is a negative sign? Tell me if you see the superscript as a negative sign.
Yes, sir, above the 2.
Above the 2, very good. So it means then that I'm investigating the limit. I'm investigating the limit as x tends to negative 2 to the left. So I'm looking at the limit to the left of negative 2. I want you to look beneath that, and then you see me calculating of the limit as x tends to negative 2 superscript plus. What do you think the superscript plus is?
So you're saying that these signs is saying that they're superscript, those signs?
No, yeah, but tell me what that plus sign is. Yeah, it's a superscript sign, but tell me what that plus sign is saying. I'm looking at it to the what?
Positive?
Yeah, man, but what is positive? Where is positive?
The right.
To the right,
sir.
Very good, to the right. So do you think that this comes back to piecewise? Sorry, not piecewise, the intuitive approach? When we look at the limit of a number, we have to look to the left of the number and the right of the number. So it is approaching the number from the left, and it is also approaching the number from the right. True or false?
True, sir.
The number line.
Yes. And that's why when I was teaching the intuitive approach, I drew the number line. Anybody remember me drawing a piece of the number line and showing you coming from the left-hand side and then going from the right-hand side? And if the answer from the left-hand side equals to the right-hand side, I say that the limit is of a good behavior and that the limit exists. Anybody remember that story?
Yes, sir.
Yes, sir.
It's exactly what is happening now. It's the exact thing that is happening right now, right? The exact thing that is happening now. We need to look to the left and to the right of the number, and we're going to check to see if it is of a good behavior. And if it is of a good behavior, then we can say that the limit of the function exists. So let us check it. Just remember, when I have the limit as x tends to negative 2, and you have a superscript with a negative sign, it means that I'm looking at the left of negative 2. When it has a plus sign, it means that I'm looking at the right, to the right. So negative, in this sense, is going to connotate something that moves to the left. So anytime we talk about left is negative. Anytime we talk about right is going to be positive. All right? Okay. So work with me now, because we have to look at these inequation signs. Those are the key indicators that will let us know whether or not we are going in the right direction. All right? So work with me now. So let us go back to the first piece of the piecewise function. It says 2x minus 1. It says 2x minus 1. X is less than negative 2. So what it is that you're doing, you're saying is less than to the left, the negative 2 superscript negative sign is to the left. So you're going to be looking at the function in the piecewise to see which of them is going to be corresponding to negative 2 and going to the left. And you recognize that 2x minus 1 is such a function. You're looking at your piecewise to see which of the function corresponds to x equals to negative 2 and that it is moving to the left. It is moving to the left, but it is less than. So one of the things that you can look at is less than is corresponding to the left. Less than is corresponding to the left. L and L can't go wrong. Less than and left. So less than is corresponding to the left. So anywhere in the function. So you see, what I explained just now would have been the intuitive approach. And then from the intuitive approach now, we're going to jump into the algebraic approach. We're jumping right now into the algebraic approach. Do you remember me saying to you that this topic is going to encapsulate every single thing that we've learned from start? The intuitive approach and the algebraic approach. So I am going to now assume in 2x plus 1 that the value of x is negative 2. So what I'm going to do is anywhere in that function 2x minus 1, I see x, I'm going to put negative 2. So 2 times negative 2 is going to be negative 4, and negative 4 minus 1 is going to give me negative 5. So I am evaluating the limit of that function to the left of negative 2 to be equals to negative 5. To be equals to negative 5. All right? To be equals to negative 5. And then now, remember at the bottom part here, I have x is less than, x is tending to negative 2 to the right. Let me ask you the question. Let me ask you the question. Look in the piecewise function. Look in the piecewise function and identify for me the function. There are 3 functions in the piecewise. Identify for me which of the functions in the piecewise deals with x moving to the right of negative 2.
It's the middle one.
Very good, Crosswell. Everybody sees what it is that he's talking about. He says the middle one. Name it the middle function, Crosswell.
Sorry, repeat that.
Name it the function. You said middle one, but I want to name it the function.
X minus 3 such that.
Right. No, man, that's fine. Just say x minus 3. That's a function. Right. So don't tell me middle one. Just tell me the function, x minus 3. No, very good, Crosswell. Everyone in the class sees why x minus 3 is the function in question?
No, sir, I didn't see it.
All right. Take one more look at
Yes,
it.
sir.
I won't. Somebody said yes? Okay. Why is it x minus 3? No, you said no?
Sir, no, I said no.
You said no. All right. I'm going to ask you to look again. Hear my question. And I think I gave away the answer when I asked. My question was, at your piecewise function, to see which of the functions deal with x moving to the right of negative 2. Do you see why he says x minus 3?
Oh, yes, sir. Mm-hmm.
Why?
Because if you look on the second working out, you see that it says minus 2 moving to the right, and it has x minus 3, which is the middle equation.
Okay, all right. But there are 2 reasons. The last equation is dealing with x being equals to what?
X equal to R over there. So then 2. So none of the other one them not have that.
X equals to positive 2. The other one is talking about x equals positive 2. So remember, my question was -2, so we can't use the last one. So that's what I'm saying to you, that I gave away the answer when I asked you the question. So you can't use the last one because the last function is when x is associated with a +2 number. In this your question, I was asking which one. So let me help you to read this double question. It says x is greater than -2, but x is less than or equals to +2. When you have a double inequality, you read from inside out. The double inequality is read inside out. The double inequality is read inside out. So you're going to look at the variable, then you're going to read to the left, come back to the center, then you read to the right. So let us try that. We're going to the middle, where the variable is. The variable is x. We're going to the left. X is greater than -2. Tell me if you can see that now, class. Hello, somebody? Hello?
Yes, sir.
Sorry, you asked a question and my internet broke up.
Oh, never mind. So I'm just saying, look at the double inequation that I have, and I want you to go to the variable. We're starting from the middle. So put your finger on the computer screen or your phone screen at where x is. The middle one, the one with the double one we're talking about now, at where x is. And then you're going to move your finger to the left. So you're reading the inequality to the left. And what is read there is going to be x is greater than -2. Tell me if you agree with that.
Yes, sir.
Very good. Go back to the middle for me now. Go back to the middle for me. Read it to the right for me now. Do you agree that it's saying x is less than or equal to +2?
Positive, yeah.
Very good. So this is how the inequality is read. It is the double inequality is going to be read from the middle to the left, then the middle to the right. Middle to the left, middle to the right. Every single time. Every single time. All right, so let's go. So you recognize now that you now need to identify a limit from the piecewise function that is going to be investigating the limit as x tends to -2, going to the right. When you go to the right, it's going to be greater than. Anywhere on a number line, and you move to the right of the number line, your number's getting bigger and bigger and bigger and bigger. Talk truth.
Yes, sir.
Yeah, man. So we say that it's greater than. So we are going to identify the function x - 3 as the function that deals when the limit goes to the right. So therefore, anywhere in the function, I see x in x - 3, I'm going to substitute -2. So it now becomes -2 minus 3, and that is going to give me -5. Remember, when I'm adding two numbers and the signs are the same, I add both numbers and put back the sign. So -2 plus -3, the signs are the same. I'm carrying forward the sign. So it's going to be negative. And then when I add 2 to 3, I'm going to get 5. So my answer will be -5. So having done that algebraic approach, I'm going to go back now to the intuitive approach and hear what the intuitive approach says. Since the limit as x tends to -2 to the left is equals to the limit as x tends to -2 to the right, then f of x is continuous at x equal -2. So technically, we are saying that the function is of a good behavior. Why, sir? Because the limit to the left is equals to the limit to the right. So the function exists. Remember I said to you when we're doing the intuitive approach, if when you look at the function, when you evaluate the limit of the function from the left and the right, and both give a different result, we can say that the limit does not exist because it is not of a good behavior and it is telling stories. But once it is that both limits to the left and the right result in the same answer, the limit exists. And you can say further that it is continuous. Are you following?
Yes, sir.
Does that make sense? Somebody talk to me. I hear Crosswell answer.
Everything we need if we just run through
The
All
last.
the last.
right.
Yeah.
Okay, no problem. What I'm going to ask you to do for me, I will run through it, it's not a problem. Don't feel no way about that. But what I want you to do for me, I am going to mute for about 3 minutes, and I want you to go through. See, I put it back on the screen. I want you to go through what it is that I just did a while ago in 3 minutes' time. In 3 minutes' time. And then I'll come back to you. 3 minutes time I'm giving you.
All right, sir.
Hold. How we stay?
Still trying to wrap up money, sir.
All right. So let me say it again. This is the only thing I'm doing in class tonight. But one of the things that I want you to do is to make sure that you can at least do a question on your own in class before we go. So let's go. So I don't have a problem going through. So let's go again. So the question says, determine if f of x is continuous at x equals -2 and x equals 2. Given that the function, the piecewise function, is going to be equals to 2x minus 1 such that x is less than -2, and x minus 3 such that x is greater than -2 but less than or equals to 2, and x minus 1 such that x is greater than or equals to 2. All right. So the first point of investigation.
Sir, before you continue,
Sure.
it's because you find the continuous, that's why you didn't have to touch the third x minus 1, such that x
is greater than equal to 2?
Is greater than equal to 2.
All right. I'm going to come to that. Lottie, I'm coming to that.
Okay. All right. No problem.
There's a secret that I want to show you, but I'll come into it.
Okay, sir.
So what I'm saying to you, remember there are two things in question, you know. Question number one is it continuous at x equals -2? Is it continuous at x equals 2? All right, let me jump into answering your question now, Lottie. So the question is it continuous at x equals -2? I am investigating. You notice I say at x equals -2. Lottie.
Oh, yes, sir. I'm here.
All right. Look at the last one now. What number the last one is talking about?
X greater than or equal to 2?
Is that -2 or it was +2?
Plus +2. So it's going to the it's going to the right.
No. That one not go to the right. But
yes, it's going to the right.
But here my question now, Lottie. Which one am I investigating? I'm investigating what? X is what? At
x to the to the -2.
Right.
Okay.
But the last piece, don't you talk about what?
Positive.
So can I use that?
No, sir. Honestly.
So which two of the functions in the piecewise function? You see the -2 beside?
The one at the top with
and the one in there?
And the one in the middle.
All right, good.
Okay,
let me just drop down to something now. At x equals +2, which two equations do you think I'm going to talk about? At x equals
middle one and last. The last one.
Tanam, that's all that there is to it. I can't use the first one because the first one is talking about
only -2.
Yeah. But no, I have to recognize now that when I'm looking at the +2 is only two equations that I can see +2 beside.
Yes, sir.
The middle one and the last one.
And the last one.
The middle one. Tell me which sign the middle one is, and tell me which sign. Okay, scrap that. Tell me where I'm going for the middle one, and tell me where I'm going for the last one. Middle one, I'm going to where? What direction?
Left.
You're going to the left, and the last one you're going to the right.
So what is hard in something? There's nothing difficult in it. Very good. But guess what? There is somebody or some bodies in the class that never saw that a while ago. There is somebody or some bodies in the class that didn't see that a while ago. Let me say it one more time. What sir is saying is, I'm investigating two things. What two things, sir? Determine if f of x is continuous at x equals -2 and x equals +2. Okay, fine. X equals -2. Sir, do you have to start with -2 first? No. But I just decided to start with -2. All right. My question now is, when I look at the piecewise function, I am looking to see which of the functions in the piecewise function, because it's one function, you know, but one function has many functions. So I'm looking at the piecewise function to see which of the functions deal with -2. Right there and then you rule out the last one. Sir, why? Because that deals with +2. Sir, how you know? X minus 1 is a function such that x is greater than +2. Oh, sir, but you're not dealing with +2 yet. Thank you. That's why I'm not interested in it. It's only the first two functions that deal with -2. So there is no way you can make a mistake in a question such as this. I'm going to use the last equation for argument's sake, because the last equation don't talk about -2. The last equation is dealing with +2. So you know, sir, an equation, the first equation and the second equation that you're dealing with. What now needs to happen is for us to decide upon now which one is going to the left and which one is going to the right. To the left is less than. Oh, sir, easy to remember that. L and L. Less, left, less, left, less than, less. Yeah, man. So when I look at the function, I recognize that the first equation, 2x minus 1, where x is less than -2. So that one there go to the left. That one there go to the left. And when I look at the middle equation, it says, remember you read inside out, x is greater than -2. That one there go to the right. Oh, sir. That means the middle equation, sir, I got used 2 times. Yes. Because the middle equation double up. It double up with -2 and it double up with +2. So it got used 2 times. A one time you're going to use the top equation and a one time you're going to use the bottom equation. Is that clear so far?
Yes, sir.
Make sure you know. Coming on, nothing can get any clearer than that. All right, let's go. So we're looking at x equals +2. So what we're doing, and this piece on here, so under the limit, tell me what me I do. This little piece may say x is going to 2 to the left. X is going to 2 to the left. X is going to 2 to the left. Hold on 1 minute, please. All right. Now let us continue looking now. No? So we're going to the left of -2. To the left of not -2. We're going to the left of +2. We're going to the left of +2. The left of +2. Let me show you the function again. The left of +2. Which one of the functions to the left of +2? Look at it and tell me which of these 2 functions. Can we rule out the first one already? Can we know say that a -2, that one they are deal with? And we know say that the second one and the third one are deal with +2. Which other function, x minus 3 or x minus 1, deals with to the left of 2?
X minus 3.
X minus 3, very good. Everybody see why it is x minus 3? Because it says x is less than or equals to 2. Listen to me. I want to try to understand this, you know. Because this accompanied me to say exam here. I want to try to understand it. Everybody sees why it is to the this is to the left of -2. I don't think you can hear me. You not hear me?
Yes, sir. We see why.
Yes, sir, I hear you.
So now answer me now. Sure.
Yes, sir.
All right, I give you a minute or 2 to just kind of you know, play around with it. But guess what? I have half an hour. I'm not gonna do one by myself, you know, so to make sure. Well, this is the last piece of it, so we'll have enough time.
Here's x is less than.
I don't know, but somebody might open.
I was gonna ask you, Lottie. So I hear say x is less than, Lottie. But look at it. Remember, when it
So
is
you
less,
can go ahead.
when it is less than, remember you go to the left. And when you go to the left, it is going to be negative. When you go to the right, it's going to be positive. You see that?
Yes, sir.
Mm-hmm. The rest of you, look here, so for me. The double inequality is saying, remember, we're reading from inside out. We're reading from inside out. So work with me. Dane is still with me. Is still with the teacher, Dane?
Yes, sir.
Okay, good, good, Papa, good. So x is going to be greater than -2. But sir, and a -2 we are dealing with, a +2 we are dealing with. Very good. x is less than or equals to positive 2. So this x minus 3 here, so is going to be the less than function. Is going to be the less than function. So therefore, x minus 3 is going to be 2 to the superscript negative because there's 2 to the left. Now, what it says is anywhere in the function x minus 3, I see x, I'm going to assume that that number is going to be 2. So I'm going to substitute 2 there. So 2 minus 3 is equal to negative 1. Two minus 3 is equal to negative 1. And then to the right, I'm going to have x minus 1. Anywhere in the function, I see x, I put in 1. So I'm going to have 2 minus 1. 2 minus 1 is equal to 1. Are those two numbers the same?
Yes, sir.
Look
No,
at
sir.
it.
No, sir. No, sir.
No, sir, you have a positive and a negative.
What
So when you work them out, when you work the two equations, then you get the same answer. It's continuous, and then you put it back and say it's continuous at whatever value you use to check it, and then now if it's discontinuous, if you work it and both of them are not the same. Okay.
Arthur Lee,
Yes, sir.
what you eat for dinner today?
Chicken and rice, sir.
You know, so the chicken well seasoned, you know. Because you're right. Very good, honey. And students, this is a sort of environment that I'm trying to create in the class. We're going to be speaking up so that I can hear you, so that I can correct your misconceptions. She said it right. Since the limit to the left is not equal, that's what I mean not equal, is not equal to the limit to the right, we say f of x is discontinuous. At x equals 2. Question done. But if you know me well, teacher will want to help you out. To the left means less than. See the less than sign here, so? And it's negative. To the right means greater than. See the greater than sign here, so? And it means positive. I want to stop and think back to the number line. Stop, think back to the number line. Every time. Stop, think back to the number line. All right? X tends to negative 2, superscript negative, means x tends to the left of negative 2. And the plus sign means it tends to the right of negative 2. The double inequality, you're going to start at x, the middle piece. It is read x is greater than negative 2, you're moving to the left. X is greater than negative 2, and x is less than or equal to positive 2. Work with me now. The last part is where I'm very concerned. Since we read in this region of the world, from the left to the right, once the inequality sign opens to you, then it is greater than. Watch me. We read from left to right, you know. So we there so, and we are go so to the left. So since the inequality sign open up its mouth, like it go bite we up, to us, it means it greater than. In other words, the mouth of the alligator is open. See it so? Greater than. Otherwise, it's going to be less than. The mouth of the alligator is closed. Tell me where you get from that. Did these 5 points add any value to what it is that we just did a while ago?
Yes, sir.
It does.
All right, cool. You're welcome.
Thank you.
You.
All right. So you're
So you
doing
have to give me one fraction though.
you think you're here for your pretty looks alone, Otto? No, man, you're there for more than that. Come. On the mark, get set, go. Start from it. Take up the question so that I can scroll up so you can look at my working out for the first one, please.
Sir?
Mm-hmm.
Sir, you're going to post this, right, sir? Because I just come because there's a lot of traffic on the road coming to Portmore and I'm lost.
All right, no problem. We'll talk. All right, have you taken out the question, guys?
Yes.
All right,
Yes, sir.
I'm gonna scroll up. I'm scrolling up. I'm scrolling up. I'm scrolling up. I don't want to. All right, I'm scrolling up to that example so you can look at it to work the first part of the thing. If you want, there is no rule that says you have to work the negative part first. Matter of fact, sometimes you get one negative and one positive. Sometimes them can give you two negatives. Other times them can give you two positives. So there's no rule, but whichever them want to work out first, your prerogative. All right, so go on from it, please.
So scroll down on the question just a minute. I'll have one last. What we, oh, so you said we can work in, it don't matter if we're at -4. Okay, cool. All right, now you can go back.
Sorry, can you go down to the question, please?
So finished.
Very good, courage. What about the rest of you?
Doing the final one.
All right, cool.
So can you go up to the example, please?
Sir?
Yes, Pop.
You can go back down. I want to see the last part of the function. Okay.
We finish it? I mean, other than courage.
So sir, for the first one, for the first function, when I did the calculation, x came up to be shall I speak it?
Go ahead.
Yeah. When I did the first calculation for the function, which is the half, when I did it, I got what's the term now? 1.
You got 1.
Yeah.
Right, okay.
The sign that's beside the negative 4. What is it? What is it again?
The sign. So that's look at the screen and tell me that's what you got.
The first function.
No, look at the screen.
Yes, sir. That's what I got as well.
It means if you're talking behind, I don't remember the term that you sir used. You're talking in negative when it's going to the left and when it's going to the right. That's what you're saying?
No, not that one.
Okay.
I'm talking the first function. Half x plus 3.
See, there it's on the screen.
Yeah, it's 1. It's continuous.
Yes, sir.
So in like say missing Mr. Tester, do we have to like draw graphs?
Oh yes, sir.
I guess I should ask this from now. So since it's going to be like you're going to video recorders. We're going to be using the camera, sir. Is the case that if we were to do like things like draw graphs and that, we would have to show that as well?
No. It's not. No. What you're gonna do? You're gonna do it on paper, and then
That's exactly.
and then take a photograph, copy it to a Microsoft Word document, and then upload all of what you're doing.
That's exactly what I'm referring to.
No man, you forgot to take it. They're gonna do the work on paper.
We just want to know how is it that we don't go.
Yeah, man. I will demonstrate to you how we do this stuff. But ideally, you're going to do the work on paper or in your book. You're going to take photographs of the paper. You're going to arrange those photographs in sequence in a Microsoft Word document. So you're just going to upload one document. You're not uploading 10 photos that you've taken. You're going to put all those 10 photos in a Microsoft Word document. You send that Word document off to me through the platform. I mark it. I grade it on the platform. The grade automatically adds to your grade book. And then I will email you a copy of the mid-semester so you can see what it looks like.
Okay.
So I give you some levels of feedback. Not a difficult process. Easy to navigate. All right. So you're with me with that one, with one. What did you get? So yes, I heard. Oh Lord, who was it? Was it Otto or Lottie? But I heard one of my females said, yes, sir, it is continuous at x equals -4. Courage, what you got? You got that to Courage?
Yes, sir.
Good job.
It wasn't me, it was Otterly, but I got 1-1. I got
1-1. Yeah, man. Otter. Hey, Otter. Trust me, mother, chicken and rice. I got all nice, you know. All right. I guess you guys think that I'm a foodie, but never mind. All right. What you get now for x equals 1?
11.
Sir, 11.
11. So let me ask you a question. How you find the limit of this function right here? So 11, it's 11 is greater than or equals to 1. How you find that limit? Hello,
Sir, times it by 1.
There's no 11x there. It just say 11.
Place value?
Isn't it that the constant is always itself or something like that?
Say that again. Who is that speaking to me? Sharifa, that's
Sharifa. Yeah, isn't the constant always itself?
Sharifa, I'm gonna buy you. Missy no. I'm gonna buy you. I'm gonna buy a pack of cheese chips. Very good. The limit of a constant is a constant itself. Very nice. Very good, Sharifa. Nice. And the rest of it is correct, you know, because yeah, the answer is 11, I think. Yeah, the answer is 11. So it is continuous both ways. So see, remember or recall, the limit of a constant is the constant itself. Let me tell you what I'm. Shantibu, unmute and talk to me. You understanding? Oh, you're so quiet tonight. You understanding? Oh, she's not here. Oh, yeah, she's here. Shanti, you understand?
Sure.
You sure?
Sir, you presented the answer in the chat.
Oh, okay. See, I didn't remember that there's a chat. You must remind me to check the chat, you know. All right, very good, Shanti. Tariq, how you stay? Tariq, how you stay? Dean, you all right?
Yes, sir.
Nice, Papa. Cherry, how you stay? Yeah, when I go on,
Sir?
Oh, you stay? Me I talk to you now. Answer me. Oh, you stay?
Oh, sir, yeah, man, I'm good.
You're good.
Kinda, because my Wi-Fi did go again.
Okay, never mind.
I'm playing catch up.
That's the struggles of life.
But
all right.
You
have it. Nice. All right. So I'm seeing that we have 1 or 5 minutes. My question to you, because I'm gonna. Sir, so you can get a piecewise function with it.
All right, so
What you say a while ago? Say homework this?
before you say anything, based on this function, the first one would be, since x is 3, 2 times 3 would be 6, minus 9 would be negative 3.
Okay. And then?
3 minus, the next one would be x minus 3. And since x is 3, x minus 3 would, 3 minus 3 would give you 0.
So therefore? Therefore, continue.
No, I'm trying to remember the
Somebody help him out.
I'm trying to remember what exactly the terms mean again.
Discontinuous.
All right. You see what happened a while ago, guys? Ouch. You see what happened a while ago? That student of mine, I won't call her name, you know, that chicken and rice now go down so good. That a homework. But you see what happened? In a jiffy, the question was solved. In a jiffy. Very good, Crosswell.
All right, so sir, before we move on, when I was doing the homework on Edicasoft, I noticed they would always mention, like, say, to find the discontinuity.
Same difference.
Huh?
Same difference. So discontinuous.
Yes.
The function is discontinuous. Find the discontinuity of the function. Same difference. Past tense, present tense, present continuous tense, all of them something that is same something I'm gonna ask you. But I need to say something though. It's when Crosswell asks me, before I say anything, sir, 2 times 3 is 6, minus 9 is negative 3. 3 minus 3 is equals to 0. I stopped and I allowed him to speak. And then I said to him, what's next? Him not answer me, but courage came in and said, discontinuous. Let me tell you what is happening. There is evidence of work being done on the platform. So when you do the work and sir comes to class and sir is going through, it makes the understanding even more because you were semi-prepared. And I say oftentimes to my students, in order to be successful at this calculus one, put the work in it. The ones who don't really get the stuff done up, you know, and somebody spoke about it last week, you know, I was playing around with my Edicasoft, and that's why I never get through with the course. And when you play around with the Edicasoft, you're not concretizing the concepts. Students, get familiar with your Edicasoft. Start working the question then. And I promise you, no teacher never...
I'm doing the practices because the homework is a part of the mark, right? And I remember when I started the homework, I didn't do well because I didn't get enough practice. So I'm taking the approach of working the practices first. And then when I finish the 3 sets now, we do the homework.
Fair enough. That's fine. That works for me. So
I'm doing too, sir. That's what I'm doing. I'm doing the practices first.
Fair enough.
Because me the way behind.
Sir.
Yes, Courage.
I have a question concerning this thing we just did. The function that says 2x minus 9. What was that column called? When I think x is less than 3, right? And we say, and we're going with the approach x approaches 3. And when we're using the algebraic method, we say x is equal to 3. So if x is equal to 3, why do we still use the 2x minus 9 when x is not less than 3? When 3 is not less than 3 instead?
Very good. So remember now, what is happening is this piecewise function has just one, it's 2. So it's just one value that we're looking at, 3. So if I look at this, Courage, this is to the left of 3 and this one is to the right of 3. So this is like the intuitive approach. So you're investigating to the left of 3 and you're investigating it to the right of 3. But this function is a function that is to the left of 3. And this here function is a function to the right of 3. So I have to investigate now. In order for me to investigate the function to the left of 3, I'm going to assume that x is 3 and see how this function operates. Remember, you know, what we're doing is piecewise function. So I need to see, so the function is defined to the left of 3 by 2x minus 9. And then in the other instance, the function is defined to the right of 3 by x minus 3. So I can give you this very question. No, lie. I can give you another question to the left and to the right of 3. And the question becomes continuous, but something has to change. Some function has to change. And when we get to the point of sketching the graph, I'm going to come back to these questions incidentally. And when we get to the point of sketching the graphs, you will see what I'm talking about. The graphs will go haywire because there's going to be a break in the graph. There's going to be a break in the function. All right. It's now 7:02. I'm going to run to another class, but I'm going to say it to you again. Congratulations. You guys are doing pretty well. There are some of you that are still non-talkers. Need to hear from you. There are some of you I'm seeing in the chat. You're just creeping at the I class and don't even say good afternoon or good evening, sir. Right? And I don't even know if I must say the same thing to only, you know, but I'm just going to let you know that there's a WhatsApp group. If you're interested, you need to get the information. All right. So I'll communicate with you between now and Thursday's class, God's willing, so I can maybe send a challenge question for you before class. So I'm going to send a question or two to you to see if you can do it before class on Thursday. All right. And as soon as this recording becomes available, I'll send it off as per usual. Go, Joe. Quickly.
So where the recording post in the Edicosoft?
No, the YouTube channel.
Oh, your YouTube channel. I was looking for it.
Yeah, man. And the channel description is in the description of the WhatsApp group. The channel
okay.
address.
Okay. Okay. All right.
Yes, Jojo, go ahead, please.
Sir, at the moment, I don't have access to my email or access to Edicosoft, so I'm not able to do anything on it.
I don't understand you need to have access to Edicosoft.
Sir,
Everybody has
I
access
have
to
to
Edicosoft.
talk to you privately about that, but I don't have access to my email at the moment.
Yeah, but fair enough. But everybody has access to Edicosoft. I give everybody
Sir, I'm
access.
not seeing anything on it. That's what I mean to say.
Oh, you're not seeing anything on it. So you log on, but you're not seeing anything.
Yeah.
So that I'll have to fix. But everybody has access to it. All right. All right. All the best, guys. Running to another class. We'll talk.
Thanks and same to you.
Yes, sir.